Dzień dobry. Wow, okay, there's a lot of people here. You know, the best thing about Android is the community, is how many people are doing it. And wow, there's a lot of people in Poland interested in Android. This is great. All right, so today, oh, how many people went to the party last night? I remember most of it. It was a great party. It was really fun. But I'm a little hoarse today. You know, I was all worried about drinking too much, but apparently I talked too much. So I'm hoping that this 2 hours will be interactive. Please ask questions. And before I try to answer any of the questions, I'm going to try to get you to answer them. Because one thing I've learned while developing in Android is that there are a lot of questions. The documentation is constantly improving, but there's a lot of things that are not documented, especially about all the different devices. But there's a great community. And if you find a question, someone else has the answer. So I'm guessing that for the questions that we have, someone else in here will have the answer. And then I talk less. So, all right, how many of you have generated the Hello World application for Android? How many have never done anything on Android yet? Half and half, perfect. Okay. So today, I'm going to try to give you some foundations. I'll go over very briefly what you need to get started, but I'm not going to go into a ton of detail on the basics of getting set up because there's a lot of good information on that online. What I'm going to try to give you is some of the concepts that are hard to get out of the documentation. So we're going to talk about life cycles. If we have time, I'll talk about alternatives to store data, but there's a flexible amount of material in this presentation. So the more questions, the better, and I'm not going to worry about running out of time. All right. This is the world of Android, according to me. And to start with, I can't talk about Android without talking about Legos. So when I was very young, I played with the Legos that were just rectangles, the little blocks with 2 lumps or 8 lumps. And those rectangles are like Java. Java has the building blocks to let you build anything, but most of it's not going to be easy. It's going to take a whole lot of those little blocks and a lot of putting it together. Then when I got older, most of our Legos were like this space station here. And the thing about this space station as opposed to the little blocks, for one, you can build something impressive really quickly because it has these great big pieces. On the other hand, if you wanted your space station to be 2 lumps narrower, you're out of luck. Then you have to go back to the itty-bitty building blocks and build something yourself. So Android gives you both options. But there are lots of good reasons to use the big pieces that Android gives you to make your application fit into the Android ecosystem by conforming with the other applications and making use of what's available. We'll talk about some of those things that are available today. So there's a couple advantages to this. One is that you can build something impressive quickly. I find developing for my phone really fun because I'm often surprised how quickly I can get something working for my own device. And I'll show you later, we'll look at the application that I built, which integrates with contacts, with the gallery, with Gmail and Twitter and messaging and anything else that can send. And it does all of these things with just one activity, just one screen that I wrote, and a bunch of screens that other people wrote. Because when you build your space station using these big fancy parts, Your space station fits in with all the other space stations. Your application provides a consistent user experience with all of the other Android applications, and that's a good thing. The biggest reason to build a native app, other than hardware access, and there's offline access, and okay, there's a lot of reasons to build a native app, but a big one is user experience, and for a good user experience, you want to integrate smoothly. And the other thing is, this space station car can drive over to any other LEGO space station and fit in, and that LEGO space station will give it supplies and it can take those back to yours. So all the space stations are on the same team when we use the big pieces and don't try to get around what Android has provided for us. Okay, enough about Legos. Okay. Next, I'm going to zoom in. We're going to start from the experience of the owner of the phone and zoom in down through applications and processes to the OS level to see how this works. So the goal in Android is for the owner of the phone to have a consistent experience. It looks to the person operating the phone like all the apps are open all the time once they're open. That's not really how it works, but that's how it looks. So let's zoom in a little bit. Here, for example, is a screenshot of Amazon's MP3 application. And to the user, the owner of the phone, this is just one screen. But I can see that it's clearly integrating with the media on the device, that this music player, that Amazon didn't write the player for the music, that is built in to the device. And there's some network access going on that's going to be a separate component too, which may or may not be written by Amazon as part of this application. Okay, so what looks like one application is really a bunch of different parts, some of which were written by Amazon and some of which are completely separate. So there's an activity, I'm using rectangles to represent activities, that Amazon wrote that lists the music and provides some buttons. The music player is a service, probably written by Google. There's a content provider involved here, which is probably the one built into the phone, because this app is giving you access not just to music you've downloaded from Amazon, but all the music on your phone. That's a great integration point. And there might be, hypothetically, a broadcast receiver that, oh, maybe it notifies you when a download is complete. So those are the 4 different application component types. And any Android application will implement some or all of them and integrate with some or all of them that already exist on the device. So there they are, the 4 components. And in the middle sits the Android operating system. Okay, so applications on Android are different from on the desktop. On the desktop, you build your app, and it starts when the user starts it up, and it ends when you exit, when your code exits. Android's not like that. The applications in Android are really built of these parts, and these parts all operate separately. This is why, for instance, in the media store, Android can list the music, but I can use the component of the media store application. I can integrate with its content provider. So your application becomes more than just your application, but also less, because you don't control when your application starts up and shuts down. The OS does that, which is a different sort of mindset. You really have to think about, what am I going to do when my application is closed down? Because you don't control it. So these represent processes. The different processes running in iOS, they each get their little Dalvik VM. Dalvik is Android's version of Java. And in this Amazon application, for instance, so we've got the activities, and probably the download service was written by Amazon, and those will run in the Amazon applications process. But the music player is its own, in a different process, and the content provider that gives access to the music on the device is in a totally different process. So this is the relationship, and let me show you what this looks like on the device. So I've got my phone hooked up, and if you haven't done anything in Android before, you'll find really quickly that the best tool is ADB. This is the Android debugger, and it gives you access to all kinds of crazy things on your phone when it's attached. All you have to do on your phone is enable debugging. That's in the settings somewhere. And then as soon as you hook it up, you can do stuff like logcat. Oh, come on, work. You worked a minute ago. I totally tested this. And here's a useful trick. When in doubt, kill the server. Is it going to work? Oh my gosh! Okay, well maybe we won't see the top. I can't believe that. I tested this 2 minutes ago. Anyway, we'll come back to that later. Maybe it'll behave. You can kind of see what's going on over here if I scroll a little. Come on, scroll up. Okay, so here's a screenshot of a top over here. If I click on that, will it go? Yes, sweet. Okay, so it looks like this, and you can see the applications. They're identified by their package names, and that's important. When you identify your application, you'll have to be sure your package name is unique, because that's really the official identifier for your app. And they're running, this is the Linux user. So what you see here, the important piece, is that each application has its own user. So while the owner experiences the phone as if they are the only user on the phone, underneath, Android uses the Linux user concept for application security instead. So, whoops, there we go. Each application has its own directory, it's in internal storage, and its own user, and its own process. And inside that are all the different components running. The important thing about this is how Android sandboxes your app. It's in its own VM, in its own process, so it can't screw with anybody else's memory. And it's in its own Linux user, so it can't screw with anybody else's data. The only data security on the Android device is this Linux file system security. The database, for instance, if you use the SQLite database, there's no security on that database. There's no users. You just open the file. But you can't open the file unless you have access. Now, if you root your phone, then things are different. Because if you root your phone, then you are a root user on Linux, and you can access any application's data. But I don't root my phone, because I don't want to force all of you guys to root your phone to run my examples. And so when I log into my own device through ADB shell, I can't see the data for my own applications. Only my application can see the data, because it belongs to my application's Linux user. So that's the close-in view of how applications really work. Okay. So later on, I'm going to talk about lifecycles and intents, and if we get to it, data storage. But I want to switch over and do the getting started thing. So everything in Android starts at developer.android.com. So when you want to get started, you go to Develop, Training, Get Started. And this part's pretty darn well documented. So, there goes, kind of. All right, so the first thing you get is the Android SDK, which you would think would be the software development kit that would let you develop the software, but it's a little more complicated than that. What you actually get is the SDK manager, and then you have to go download some more stuff from within here. So the first thing you download is always get all the tools. You need that. And then you need to pick at least one API level. So here, this is a really core Android concept too, this API level. And the key is in this dashboard. All right, this is an important page. This shows you the operating system versions, the name that we call the operating system colloquially, and then the API level. And that's the Java API. It determines what programs and methods and classes you have access to. And this shows you, for the last 2 weeks, in phones that have accessed the Google Play market, what OS people are running. So when you go to develop an application, the first thing you have to decide is, what version am I writing it for? Yeah, we are not in iPhone land here. So I can point with this. Generally, people are going to move toward upgrading. So if I were developing an app for the market, I would definitely target Gingerbread. Here's Jelly Bean. It's the most recent. My phone is running Jelly Bean. And Honeycomb is the version that came out for the tablets, really. So my tablet is on Honeycomb 3.2, as it happens. And a lot of people are still running Gingerbread. So I would target that one if I was developing for the market. For my own purposes, I target Honeycomb because that covers both of my devices. So once you decide on an API level, like I'm going to pick 13, then you come over here and you download that. Click on Install Packages, blah, 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 and a whole bunch more things download. It takes forever. The other thing that you need to know about this SDK manager is up here in the Tools menu in this obscure spot is where you can set up emulators. AVD is, yeah, Android Virtual Device. So this is where you can set up emulators, and you'll need one for each API level. And this is how you test your application on devices that you don't own. Because the hardest part of Android is testing, because all the devices are different. It's just crazy. Okay, so once you get that, then you can download your IDE plugin. Google's official IDE is Eclipse. I'm an IntelliJ user. I like IntelliJ, so I use that. Both are free. Both have good Android support. Okay, and then once you get here, new project, Android module. All right. Next, blah, blah, blah. All right, so people who are first learning Java, especially people who are new to programming, think it's completely crazy that in order to print out hello world, you have to like create a class and public static void main string args, whether you want those arguments or not. And then you can finally system.out.println. Okay, well, Android makes Java's hello world look trivial. The hello world in Android is complicated enough that nobody ever builds it from scratch. You generate all your new projects. All right. So when you create the Hello World project, and you can do this from the command line. You can do all of this from the command line. You do not have to use an IDE. But why would you use Java without one? Okay. All of this is Hello World. And there's stuff inside here. By far, the most important things are in the Android manifest. This is the definition of your application. This describes all those components that are part of your application, both the ones that your app uses and the ones that other apps can use. So this one's critical. Your package name is essential. Ooh, I should have changed that. I better leave it as example for now. I should have changed that in project creation. So your package name should be unique, and that's what really identifies your application. Version code will be used when you upgrade your app much later. And here's that SDK version. That's very important. And finally, there's some stuff that's not in here in the Hello World app that you're definitely going to need. One of these is use as permission. There they are. So permissions in Android are really interesting because I talked about security being by the Linux user, and so the permissions that you request in your app are the permissions that Linux user gets. And the interesting part about the application I'll show you later, that it can send an email, it can tweet, it can send SMS, it can let you pick a contact, it can do a lot of things, but the only permission it needs on most phones is read contacts. And it can do that because when it integrates with those other applications, when it sends its little spaceship car over to the other space stations, and the components of Gmail, for instance, are running in the Gmail process, then those components have Gmail's permissions. And Gmail can send an email even when it was launched from your application. But when you're setting up the permissions you need here for your application, you'll put them in your Android manifest, and these are the ones that when people download your app, they'll have to agree to them. That's my favorite. All right, one more thing that I recommend you always add here, support screens, the large screens and extra large screens. The default varies by device. You want them to be true because otherwise this is a large screen by this definition, and even smaller phones than that are large by these standards. And if you don't specify that your app supports that, it'll do some really hideous scaling thing. All right, so those are two things you could add. So your application is defined here, and this is interesting. @string, app name, what is that? Well, these little @ symbols in attribute values refer to resources. So if we click on this, is that big enough? Ooh. Then we can see where we are. Aha! We are in the res directory. So the res directory, res is for resources, and this holds all of your strings for internationalization, and it holds your pictures, your icons, stuff like that. So one thing we can do is we can internationalize our application. If I go here and say new resource file, this is not easier than doing it manually. We'll get a new strings.xml, which is a values resource, and we will give it a language qualifier of Polish. Okay, so now we got another directory, and this is really the key to the Android resources directory, is that you start with values and layout, but you can make new directories for different languages. You can make new layout directories for different screen sizes or screen orientations. And so you can have one or many resources. This is always going to default to strings.xml, but any that we override here, we can put hello in Polish. Cześć. I'm working on that one. Right? Cześć. So now our application will be cześć when I set my phone to Polish, if it will connect to my phone. All right, something else that's fun in the resources directory is we don't have any pictures in here yet. So this is fun. Let's see. What did I... Google is your friend. This is what I'm looking for. Okay, so one of the challenges of writing an Android app is providing pictures for all the different screen sizes and resolutions. And Google has some handy tools for you here. I like this. So we can make an icon for our app pretty easily. There's our little world. Put it in a circle. Crop. There. Perfect. And when we download something, we get, where'd it go? Yeah. All of these little directories, each of which contains the icon in the appropriate resolution. So, if I copy all of these and just dump them into IntelliJ right here. Yeah. Really? Dang it. Did it do it? That looks pretty good. Let's find out. All right, one thing that I like to do is set up one configuration for the device and one for the emulator. Hello to device. And then I love this about the IDEs. When I push this button, a whole lot of things are going to happen. It's going to run the whole build for Android, which Android has an Ant build, and it's not pretty. Well, that's pretty, but there's a lot of includes inside there. And one of the things that it will do is generate some code in here. Android is a really good ecosystem if you like code generation, because it's pretty efficient to generate code as part of the build and then put it on the device. And then it'll compile everything, it'll generate that, it'll compile everything, it'll package it up into an APK, and it'll shove that onto the device, hopefully. It hates me. Where is that? It did something weird. All right, it recognized that device is not available. I was afraid of that. Okay. We're going to have to kill ADB again. Ooh, okay, so while I'm doing that, who in here has developed an Android application? All right. So, what does your app do? Tell me. Personal use is good. Really, I mean, my application, I only use it myself. I'm too lazy to test it on every device in the world. But does it do anything that's useful to you? All right, maybe I should ask for volunteers instead of picking on someone. A to-do list, cool. That's always a good intro app. Who else has an application that they find useful? Come on, you guys, I need you to talk. 60976. All right, let's try again. This always happens. Yeah, I did a couple times. I have another device. So let's try this one. All right. Okay, so after Android packages this up into an APK, it pushes it onto the device, which you can do at the command line with ADB install, and then it runs it. Come here. Okay, let's scale that down. 50%? That's pretty small. That'll do. Okay, so this little jar is showing you what's on the tablet screen. our icon, it didn't work. Oh well. So if we go to applications and we find hello, the icon didn't work. Oh, I know why. So all our hello world does, of course, is print hello world. We'll make it a little more interesting, but no, not really, we won't. When in doubt, go to the Android manifest.
What was that window? Was that the same thing that was displayed on your device?
Yes. Right. So I could launch it to the emulator from within the IDE, but that's a lot slower. So I usually just launch it to the device. I also find that more entertaining. Yeah, Droid at Screen is some jar I found on the internet. So our application definition has an icon attribute. And what do we call it? IC launcher.jpg. Okay. So we put, oh, thank you. Okay. Transmit again. What did I do? Okay. I need to specify that it's a resource, and look, I even get auto-completion. So this tells Android to go find the IC launcher image in whatever drawable directory is appropriate to the device. And the little play button here even launches the activity on the device, so I don't have to do it myself. Where'd it go? That's this. Can you see it? Yeah, so now we have a little world icon and it says hello. And if I go change my settings to Polish, which I did this the other day and then my phone was in Polish for days. It took me a while to get it out. Notice I said my phone was in Polish. It wasn't the tablet. Really? Really? Well, if my phone would work, then I would switch it to Polish. All right. So we made the Hello World active, and I'm really disappointed that I can't see chest. I could make it Spanish, but then it would still default to the values with no language modifier, so it wouldn't say hola, unless I set that up in here. Okay, enough about that. Let's talk next about the one application component that's in here.
I have a question about this resource evaluation.
Mm-hmm.
You said that, for example, for this values PL, the strings are somehow overwritten over the default values for the general thing. And the same probably applies to icons. You can have the different icons for Polish, local, and so on. So how this is related to this HDPI, LDPI, which takes precedence? What's most important? Which icon is most important? Whether it's for HDPI, LDPI, or for Polish? So how this is
So which modifier would take precedence, the language modifier or the resolution modifier? I don't know. Anybody know? Anybody tried it? So you can try it, or you can go to Stack Overflow, and someone has probably also asked that question. Another thing, the tooling is pretty good in here. If I go new resource directory and drawable, and I pick language Polish, and also, wow, what do we want? Where's resolution? Density, I think. And we pick one of those, what do we get? We get a Polish HDPI. So I'm going to guess it's the language. But you know what? It probably varies by device. Most things do. Okay, so good question. The one component in almost every application, but not every application. Some applications only have services or content providers, but usually the interesting stuff is in the activities. because activities are screens, pretty much. Okay, and so I'm going to show you the different parts of the activity, and then I'll go back to the slides and talk about the life cycle of the activity. So first, the activity has a component in the manifest. That's essential. It has a name and a label. It'll default to the application's name, even if you don't specify it. And this stuff here, I'm going to talk more about intent filters later, but for now, you need to know that it needs this main action and this launcher category. That means this activity can be placed on your home screen, and your application can be started up in this activity. So you almost...
You said that we need action main to place on home screen. Is it on the home or any screen? Because you have 3 or 4 screens.
Oh, like yeah, that. I think that all counts as the home screen. Okay. Just one of them is the middle. Yeah. So if you want to place your application on your desktop, for instance, you'll give one of your activities these. You could have more than one. You could have more than one entry point into your application. But these are this intent filter indicates that. All right. And the name of the activity is also the name of the activity's class inside the application package. So when I command click there, it takes me to the source directory, and here's all the Java code. All right. So roughly, to create an activity, you extend this activity class. Lots of inheritance in Android, very OO. And there's a lot of methods that you can override an activity. The essential one for for any screen is onCreate. Always call super. There's a lot of these hooks in activities and in fragments that we'll talk about later. And in general, always call super at the beginning, some of them at the end. Now and then you'll get an error if you don't. Usually it just might not work right. Here's the essential thing to do. You set the view to an XML file. Now this is the other way that you access those resources. This goes into that code generation. Now IntelliJ is smart, so when I click on here, it doesn't take me to the resource, where that variable is defined, but that variable is actually defined here in this generated code. And this is how you access your resources from the code. This is generated as part of the build, and it has some cryptic integer for all of your resources. All right. So what's really in that XML file is this, very dull. Man, I wish I could display this in Polish. I was going to make a resource out of this, and then we could say hello in Polish again. But, all right. So linear layout, this is pretty standard. If you've ever done any swing, well, JForm designer, any sort of XML layouts, this is pretty normal. Your linear layout can go this way, it can be vertical or horizontal, and then it lines up the things inside. And then we have one text view in here, which is not very exciting. So one thing that this text view lacks that pretty much every component inside a view should have is an ID. And this is something interesting. An ID is going to be a resource, but this is kind of interesting. This little plus thing tells the code generator to generate a new resource in the ID for this view component. That has a couple of effects. One is that you can retrieve the view by that ID, and in fact it's type safe because that ID is actually a generated field inside that R class. It'll be r.id.textContents. When I access that inside my activity, Sometimes I have to hit play. That's my problem. It needs to, I should have just hit build. Yeah. Until I build it, it's not available, but somehow I triggered that. All right, yeah, I know, not a statement. It's just an integer. But the point is that you can access those IDs in a type-safe manner in your code. The other effect it has is, you'll notice inside this onCreate method, we get this saved state. So you can use this. A bundle, by the way, is just a map, really, a key value store of anything, any kind of object that is not serializable, but parcelable. Parcelable is Android's version of serializable. Okay, so anyway, you get that stuff in your bundle, and one of the things that's in that bundle that you don't have to put there is the state of all your view components. If your view component has an ID, and somebody types something in it, and then your activity gets shut down because it's out of memory and recreated later when the user comes back to your app, Android will save the contents of that text field that they just typed in for you if that text field has an ID and you remember to call super in here. So remember that you don't control when your activities are created or destroyed. You have to try to make it a seamless experience for the user, to look like your activities are open all the time, even though they're being destroyed whenever they're out of memory. And this is one of the ways that Android helps you with that. Okay, are there any questions? Gosh, you guys are quiet. Oh, good. Okay.
Can you use it in some other resources like string? Can you say plus string and then fill the string in the code, Java code?
That's a good question. I don't.
Or it's just only to IDs?
As far as I know, it only works for IDs. Although it might do something even weirder. Has anybody tried this? It might do something even stranger. If we did that, it might do the same thing it does for ID, which is just generate an integer inside the R file. It didn't have to launch. Nope. Maybe it's only IDs. But all it did for this ID, it didn't actually generate like any content. All this ID is just the integer inside R. It's right here. So all you get out of that is an integer that you can refer to in your code. All right, back to the Prezi. Uh-oh. Okay, so we've looked at the basic parts of an activity, which are the Android manifest bit, the class file, and the layout file. So let's talk a lot more about the life cycle of the activity. There are a lot of life cycles in Android. There's your application life cycle, activity life cycles, fragments, tasks, services. The activity is the hardest to get right and the most crucial. So, this is, the process lifecycle is the same as the application lifecycle. And there's something weird about Android as it's creating this consistent user experience. It looks like the apps are running all the time, but really they're not. And a difference between Android and like a normal Linux server is, so on Linux, there's limited memory, right? And in a normal OS, when you try to run a program and that program tries to allocate memory, and it can't because there's not enough, the program you're running throws out of memory and dies. That doesn't happen on Android because the program that the user just tried to open, that's the most important program on the phone at that moment. And instead of the program the user just tried to start up dying for out of memory, something else is going to die. Android intercepts that, and there's a whole prioritization mechanism based on what's in front of the user. Whatever's on the screen is the most important thing, and whatever's being used by that activity that's right on the screen is the next important thing. And then there's a whole bunch of other criteria that it uses to decide when to kill something. Whatever hasn't been used for a long time, that's going to die. So, and that could be anywhere in here. Your activity lifecycle is shorter than your application, a lot shorter usually. And then we're going to talk about fragments after a bit, and those can potentially be even shorter. But at any point in here, Android could go and kill all of it. And if you're lucky, you'll get your callbacks called first. So, in particular, the activity lifecycle is really important. We saw onCreate. So Android starts up the activity, it calls onCreate, and there you set up the view and everything else that you need to do to start up your activity. And then that troublesome owner turns the phone sideways and your activity's gone. Probably calls on destroy. Actually, in the case of rotation, your application is the most important. Your application is in the front, so your callbacks will get called. On destroy, Android forgets about that activity instance and creates a new one and calls on create again so that you can completely reinitialize your view and everything else sideways. This actually drives me crazy because it's slow, so this is why I turn off rotation on my phone. This is why it's so slow when you do this sometimes, because you're completely reinitializing the activity. Right. You can switch off rotation on your phone, but so the question was, it always works like this. You can't override this in your application, and no, you can't. There are ways to cope. You can use that bundle of saved instant state to retain some of what you had. You can also Oh, that's true. That's a good point. You can disable rotation within your application. Yeah, so you can say you can't rotate it at all. Right, right. When you want to turn it sideways, then you can't. And yeah, some applications do that. The other thing that you can do is you'll notice your activity lifecycle is potentially very short, but your application's lifecycle is the length of the process. And you can have an application class. My app has one of these, so we might look at it later. And when you have an application class, that's basically a singleton whose life is the length of the process. So you can put stuff there. And then when the new activity is created, they can use that. So like a database connection, I put that in my application object. And that way, it lasts through activity recreations. So that's a surprising thing. And this is also the easiest way to test whether your lifecycle callbacks are doing what you wanted, because it's really easy to turn your phone sideways. This one, if you have services in your application, those aren't going to be killed and recreated on sideways. Yeah. Absolutely, yes. You can use services for anything that's going to run for a long time. And that brings up another of the challenges in Android is threading. So everything in your activity, all the code in your activity is going to execute on the UI thread. So you have to be careful what you do in those callbacks. And actually, there are exceptions to that. There are some of the callbacks in your activity that don't take place on the UI thread. But in general, services are a really good way to offload things that are going to take a while and things that you don't want to lose just because the user rotated their phone.
I mean, those complex operations even can't be done on the UI thread because it's just forbidden. You get an exception. For example, if you connect to the other server, the Android throws an runtime exception that you have to make it as a different thread because
Oh, nice.
the main point is that the main UI thread has to be operatable for user. Yeah, it can't be on hold.
Yep.
On hold because the OS will kill your application or
Yes.
thread.
Yeah, absolutely. You have to watch what you do on the UI thread because anything you do will delay the responsiveness of the phone. And so is that if you bind to a service, it throws an exception immediately because it knows you're doing something bad?
It was kind of introduced later on from
Okay.
3 that if you do some complex stuff on the main thread, Android will notify the user that the application is not responding
Yes.
to the complex operation, and it will ask the user if he or she wants to kill it.
Yes.
So that's the whole situation.
Right. Yeah, absolutely. If you tie up the UI thread for like 5 seconds, Android will kill your app. And I have a setting on my phone that sets it up to whenever the UI thread is not responding, whenever something's running on the UI thread, it like puts a red border around whatever I'm running so I can see how slow everyone else's applications are. I would show you that if my connection was working. All right, so here is the larger Android lifecycle. And this picture I mostly stole off of the documentation on the Android site. But, you know, as complicated as this looks, it's actually more complicated than this. The important thing is onCreate, and we all know that onCreate gets called when our activity is started up. It also calls onStart and onResume immediately on startup. So each level in this pyramid is a level of aliveness for your activity. The top level is visible to the user. Your app has focus. You are the most important program on that device. The level 2 of the pyramid there, paused, means that your activity is still visible to the user, but not fully. So if you pop a dialog box that's a separate activity, then your activity gets paused. So it's still visible, but it's not the focus. And something to know about onPause is that gets called on the UI thread. When your activity completely loses focus, either some activity comes up in front of it, or the user pushed home or switched over to a different application, that's when onStop gets called. And onStop is not on the UI thread because your activity is no longer visible. So when you're doing teardown or saving state, do slow stuff in onStop and quick stuff in onPause. But anytime after onPause is called, your activity can be killed. It won't be killed when it's the focus because it's too important then. But once it's not, it might die. You never know. And you hope that onDestroy is finally called when either the user turns it sideways, then it definitely will be, or the user hits back, or your activity can close itself by calling finish. Many, many ways for an activity to die. Okay, so when you do want to save something, for rotation, for instance, you do that in another callback, on save instance state, which is called somewhere around the same time as on pause. Might be before, might be after. It's not determined. And that's when you create a bundle of parcelable objects. And that gets passed into the onCreate of the new activity. Now, something to watch out for is this activity just died, onDestroy was called, but that's kind of a strong way to put it. You would think, okay, onDestroy was called, that activity is gone. Well, really, Android just dropped its reference to that activity, so it could be garbage collected. But if any code in your application still has a reference to that activity, then it won't be garbage collected, and your view won't be garbage collected, and your bitmaps won't be garbage collected, and you'll run out of memory. So be careful not to hold references to activities. All right, let's talk about transmit. So this is my application that I wrote for my own use, and it makes a great demo because it does so many things. So the use case is something that I do very frequently is send the last picture I took to a particular person by a particular method. So I might send it to my husband by SMS or to my friend Mario by Gmail. And this is a very common operation. And in Gingerbread at the time, this was 9 clicks. And not just either. Click, wait, click, wait, click, wait. Way too slow. So I wrote transmit to transmit the last picture to a configured person. So the app looks, let's see if it'll run. Do I have the tab hooked up? That's Phil. He's another speaker. I don't think he's been to JDD yet, though. Okay, transmit. Looks like this. It's too big again. Where'd this scale thing go? There it is. Okay, perfect. This is upstairs. Does anyone know what that means? Please do not mouth stretched its hands out of the ice. I don't know what it means, but it's the funniest mistranslation I've ever seen. Okay, so the purpose of transmit, here if I switch to, no actually I have a menu option in transmit as well. Menu, take a new picture. I'm going to take your picture. Ooh, that's not very good, is it? Ah, so blurry. It'll do. Oops. It didn't save it, did it? Ah, what did I get? Okay. So anyway, the purpose is to take a picture. It didn't work. Save. That's what I need. All right, so in that, my application launched the camera application to take the picture. And then when I push this pick contact button, it launches the contact application to let me choose a person to send it to. And then when I push this action button to choose how to send it, it launches, well, the package manager, but it launches something else in order to let me choose all of the ways, all of the applications on my device that know how to send a picture. And whatever, Gmail. And then it creates this button over here and saves the configuration to the database while it's at it. So that now, anytime I want to send to Adam by Gmail, I can just click, don't click on the screen, click over here. I can click that, and it launches Gmail. So now I'm in the Gmail application process, but from an owner perspective, I'm still within transmit. And then I can push send in here, and then Gmail uses its permission to actually send the email. We will confuse Adam. And then the other thing that we can do is use this gesture. Oh, it didn't show you. If I draw a lightning bolt on the picture, then it brings up everything that knows how to send, and I can directly launch that without configuring a button. So each of these is a different integration. And this stuff is built in. This is not a complicated application. It does a lot of stuff, but each piece was really quite easy. The hardest part is integrating with the camera because, well, whatever. It does not work on every device. The cameras are the trickiest part of the hardware, although I hear Bluetooth is a bear as well. They're very device specific how they work. Okay, hopefully that'll go. All right, that sent us back to, didn't expect that. Okay. Great. So that's what transmit does. Let's look at the different parts of it a little bit. Okay, so there's a part that controls the buttons, and there's a part that loads the picture. And these are two fragments inside the activity. So fragments are parts of activities, and there's two reasons to break your activity up into fragments. You can do everything just straight within the activity, and in fact, that's how I wrote transmit for Gingerbread. Fragments were introduced with Honeycomb and then backported to earlier versions, so you can still use them in Gingerbread, which is good because fragments are awesome for two reasons. One is that when I turn my tablet the other direction, and I can show that. Transmit, come back. Oh, just hit. There it goes. When I rotate my tablet, what's going to happen? Okay. Well, this isn't sideways to me, but you'll notice that now the buttons are on top of the picture, and horizontally the buttons are to the left of the picture. So fragments make it easy to do that. Is one reason to use them. But the reason I really love them is because like this one activity, this one transmit activity, it launches a lot of different stuff. And I did not like having all of that in one class. So now at least I have two classes, one with responsibility for the picture and one with responsibility for the buttons. And that's a big improvement. Okay, so let's pop over and look at some transmit code. Yes, yes.
Can I use the fragments in API for Android 2.2 if I'm developing that? No.
Okay. Thanks. So fragments are backported, I know at least as far as Gingerbread. And it's not exactly the same, like in transmit, there we are. My fragments, here's one, extend fragment. It's a little different in Gingerbread, but not significantly.
Is it forward compatible from Gingerbread on?
I think if you upped the API, I mean, it'll work on every phone post Gingerbread if you write to Gingerbread. If you then decide to up the API level of your application, you'd need to make a few changes, but pretty minor. Okay, so yeah, the transmit activity sets its layout to main, and aha, when I click on that, I get two choices, because all I did to make the rotation different is create a different main.xml and put it in the -land directory, so for landscape. And the only difference between those two XML files is right here. Vertical, horizontal, swap the fragments. Very easy. So now this XML looks really trivial. It's really small, and my pieces of my application are organized into these happy little fragments. And the fragments, okay, So fragments have a slightly different life cycle than the activity. They're almost mini activities, but they're not. They're always attached to an activity. So the onCreate is different. You have the onCreate view, where your entire job is to return a view, which this is what you usually do. It gives you this inflator thing, and you inflate another XML layout. This one has the buttons in it. It has the pick contact button and the choose your action button, and then it has a container, and I programmatically add the configured buttons. But I don't do that until later. First, I just inflate the view with the basic buttons and give that back. So this is going to be called during this. As part of setting the view on the activity, it has to construct those fragments. It has to inflate them as part of loading this layout file. But then, okay, so we do this, and then we do this stuff, and the rest of onCreate, and then inside the fragments, we got onActivity created. So this happens after onCreate and the activity, and this is where you should initialize everything but the view inside your fragment. That's really the biggest difference in the life cycles. Something else to watch out on fragments is some of the callbacks to the activity also exist in the fragment, but not all of them are called unless you call them directly when they are also called on the activity. I'll show you one of those after a bit. All right, but the important ones are onCreate view and onActivity created. And this is where we create the buttons programmatically. All right. Let's go back here. We talked about fragments. Oh, goody. Now I get to talk about Pokemon. So, how many of you have kids? All right, you guys know about Pokemon. So, in case anybody doesn't, the concept is they've got these pocket monsters, and the monsters like shrink and go into these little balls. And when you want them to fight, you take one of these balls out of your pocket and throw it out there and say, Pikachu, I choose you, or whatever the Pokemon's name is. And then Pikachu jumps out of the Pokeball and does Thunderbolt and strikes down his opponent. But he never kills anyone, he only knocks them out. Okay. So Android intents are a lot like Pokeballs. And I'm going to talk about that a lot more, but there it is. Okay. And I use intents to communicate, like when we pick that contact, the first thing transmit needed to do was to let you choose a contact. And to do that, it integrates with the media application. And it does this in the way that a lot of inter-process communication happens in Android. So in Android, you've got all these different processes, and everybody's sandboxed into their own process, and yet everybody's closely integrated. So there's a lot of traffic with these space station cars. There's a lot of inter-process communication going on, and one of the major ways we do that is with intents. So with intents, we cram into the Pokeball what we want to do and hurl it out into the Android ecosystem. And then something jumps out and does what we asked it. Now the difference is, with the Pokemon, Ash yells out Pikachu's name, and with intents, we don't usually put in the name. Sometimes we do, I'll get to that in a bit. But usually we just put in the action. Like I put in pick contact. No, I put in pick and then specify that what I want to pick is a contact. And I hurl it out into the Android atmosphere. And something pops out and does pick. Or in the case of when I draw the lightning bolt on the screen, something pops out and does send. So I don't know which application is going to fulfill the intent, but I've told it what I want it to do. So here's the different parts. This is all the stuff that you can cram into the Pokeball to give Android clues about what you want to do. First of all, component If you specify component, then you're specifying a package and a class name. And then you're saying exactly which activity should fulfill this intent. But this is what you do internally in your application. Transmit only does this for the configured buttons because you've already chosen the activity in that case. So the component is the exception. That's when you specify. All right. But the more interesting ones, you always specify an action. Transmit uses pick or send. Data, in my send intent, I put that picture in there. Or you can specify the type. And I specify the picture's type so that whatever performs that send action is capable of sending a PNG or JPEG or whatever it is. Categories are optional. Any activity that fulfills somebody else's intent will have the category default. You don't specify that in your intent, but watch out because the activity has to have it or it won't pick it up. Any additional categories that you include are also required in the fulfilling intent, so you can use that to narrow it down. Flags you can use to change the behavior of how the activity launches. I'll show you what it usually does in a minute, and flags can modify that a little bit. And extras. Extras are everything else. And it's whatever, it's yet another key, it's a bundle, I think. It's yet another key value store. Actually, it's not a bundle because it won't let you put arbitrary objects. But anyway, it's another key value store, so you throw a string in there and some value for it. Transmit does this with the email address and the phone number of the contact. And the bad thing about extras is they're really not documented. This is where I'm really glad that a lot of Android source code is available online, because extras are not going to affect which activity picks up the intent, but they are where you give that fulfilling activity more information. And the bad thing is you don't know what values it's going to use, or what values it's going to look for, and whether it's going to throw a null pointer exception if it doesn't get one. The good thing is you can't put in too many. So I put email address into like 3 different extras for the various applications that might look for it in different places. Okay. So what happens when you throw that Pokeball out? First, Android, the package manager, knows about all the different activities available on the device. All the components of all applications are in the head of the package manager, and the package manager is going to select some activity to fulfill your intent. And that activity has intent filters. We saw the, let me show you one of these. Would you give me, oh, it's doing that thing, is it? I've got a link in here. So Android manifest is the definition of your application, and if you look at the source code of someone else's Android app, that is where you want to go to find out how to integrate with it. So this is the contacts application, and when I want to pick a contact, I'm going to need to launch something that knows how to pick. So it might be this. All right, so each of these activities has 1 or more intent filters, 0 or more really, that state how it can get started up. This tells it what Pokeball commands it can fulfill. So in this case, I send a pick. There's that category default that it has to have in order to be launched by another application. And these are the types of things it can handle. I ask it for a contact, so it likes that. So the package manager is going to look at the intent filters of all the activities in the whole device and find 1 or more that fit what you asked it to do. And if it finds more than 1, it's going to ask the user which one to pick. And that's what happens when I do that transmit lightning bolt on top of the picture. Well, except with send, not pick. In the case of pick, there's really, I specified that I want to pick a contact, and there's only one application on the device, on my device anyway, that will fulfill that pick contact intent. So Android just immediately launches it. All right, that's intent filters. Yes?
Have you ever written an app with your own intent filters that itself could be called by other apps?
I haven't. Who has? Anybody? I have integrated just for entertainment value. I wonder if it'll work. I don't know if I have the app on this device. Come here. Don't be out of batteries. Okay. Phew. It's getting pretty low. But inside transmit, just for entertainment value. Oh, no. So let me put that on the screen. Aw, don't be small again. The menu over here. For entertainment value, I integrated with an app that I downloaded. It's on my phone, but apparently not on my tab, called Tesla LED. And it's a really cool app that like activates the flash for the camera and like strobes it or does Morse code for you. And that app exposes a service so that transmit can tell it to flash some lights. But when I initialize the menu here, I'm asking the package manager whether it has any services, in this case, that can fulfill a flash some lights intent. And this device doesn't have such a service available, so I gray out the menu item. So I've used somebody else's. There's an interesting site, openintents.org, where people are trying, I don't know if they're succeeding, but they're trying to form a place where people can advertise their own activities that other people can use. I think that's a neat site.
One thing, you integrate with another app. Do you mean you distribute this app with you, or you just need the other app to be on your tablet or phone?
That's a good question. So the question is, if you do integrate with another app, how do you make sure the user has that app on their phone?
Exactly.
Right. Anybody have an answer for that?
Package manager takes care of it.
Well, yes. So he said you can have your application check whether that other app is there, and if not, tell the user to download it. And in fact, I've experienced that when I downloaded Ruby for the tablet, and when I first started it up, it said, oh, you need this other core framework app first, and linked me to the Play Store so that I could download that, and then I could run Ruby on my tab. So you can require it, or as in the case of transmit here, you can just modify your functionality depending on whether they have the activity or service that you would like to integrate with. So, good question, thanks. All right, so package manager filters stuff down, launches whatever the user chooses if it finds more than one. And then this is the important part. Now, from the perspective of the owner of the phone, that Gmail window is inside transmit. It was launched by transmit. If they hit back, they get back to transmit. When they're done with that email, they get back to transmit. Even if they go away and come back to the email, they'll still see the email and then hit back and then see transmit. And that's all controlled by the concept of a task. We talked about processes and applications, and tasks are another thing. Let me show you what this looks like in the debugger. Hopefully that'll work on the tab. ADB shell dump sys. This is a spell. Activity, activities. All right. This is how you see what tasks are running on your device. Transmit has its own task record. And this tells you what intent launched transmit. And here's the history of the backstack. And it should be just transmit activity is the front activity. Can't really see it because it's scrolling off the screen, but it's there. And then behind that is just the launcher. And effectively, what you get is something like this. The launcher is always at the beginning of the backstack, beginning, end, whatever you want to call it. And then whatever activity started up the application, if it hasn't finished, is right here. And that's in the transmit process. And then when the transmit activity launches another activity, that goes in the same task, but not necessarily the same process. Gmail is holding on to that activity, but from the user's perspective, because it's in the same task, it operates like it's part of transmit. So this is the other perspective besides processes. The backstack is actually really important and sometimes tricky. The flags in the intent, you can modify what this does. Also, your in intent filters, if your activity is the one fulfilling the intent, you can specify other than the default behavior. For instance, a view. If you launch a view intent and the browser fulfills it, like to show a web page, the browser in its intent filter says, put the user in my task. So when you go to the browser, at least some of the browsers, it won't create an activity in your task, it'll do it in its own. So you can override this in a lot of ways. You can specify that if my activity already exists and someone goes to launch it, don't launch another one, just move this one to the top of the stack. You can do stuff with fragments, like in Gmail, if I click, Gmail on the tablet shows, oh, I forgot to tell you that. Gmail on the tablet shows a list of emails and also the current email. These are each fragments. And what's cool about that is that Gmail on the phone shows me a list of emails, and then when I click on one, it launches a different activity that shows me the contents of the email. This is another thing you can do with fragments, is have them in the same activity in some formats and different activities in another. And now you do that programmatically. It's not in the layout files. It's not that easy, but still. All right, okay, the other thing about fragments is when I'm in Gmail and I click on an email and it loads it, and then I hit back. Normally when you hit back, you're moving to the previous activity. With fragments, you can programmatically say, put that fragment change on the backstack. It's a fragment transaction even. And that way when the user hits back, they don't leave your activity, they just back up through the fragment transactions. Very tricky, but this is an important concept, and if you're going for a good user experience, this is another of those things that you need to keep in your head and really think about and actively decide what your application should do. Okay, we have 25 minutes, I think, which is a lot. This was the really crucial point that I wanted to be sure to get to. We talked a bit about concurrency earlier. Here's another life cycle point that I want to make. When you need something, when you need to run, your activity needs to run something that's slow, you can't do it on the UI thread. So there's a couple ways to offload. A service, writing a service for it is kind of a lot of work, but it's the most effective and the safest. Another one is an async task. Like when I go to store the button configuration in the database, I offload that to an async task, ostensibly for performance reasons, but really it's super fast. Really, I just did it because it's a demo app and I wanted to demo it. So let's find that. All right, so the store button task is an async task inside button fragment And if you override the do in background method, which you have to, then you can do whatever it is off the UI thread. This will run off the UI thread. And then this will be called on post execute in the UI thread. So you can update your GUI. And then to use this, where do I use this? Somewhere. Anyway, you instantiate one and you call execute on it. Now there's a problem with this. And that problem is right here. If, while this asynchronous task is working, someone turns their phone sideways, then the activity goes away, its life cycle ends, but that async task doesn't know about it. So in your on stop of your activity, you should cancel any async tasks. If you hold on to the reference of the async task you created, then you can cancel it. The other problem is, since that was a inner class of the fragment. Ooh, a question.
What if we don't? What if we don't cancel the
You know, probably nothing. It's just going to run to completion, and then it's going to update the GUI on an activity that is dead. So if you don't, you basically just have this thing running out there that's never going to help anybody. Well, I mean, in the case of this, it's going to succeed in putting something in the database, which is good. I wanted that.
Can I do that this way, that it's reconnect the new instance of the main topic?
I wish. Yeah, does anybody know of a way to do that? Because I've totally, and actually, I was emailing yesterday about this with one of the authors of Programming Android. And yeah, he's like, yeah, I wish too.
What if an application does something that doesn't die or has some static reference? It's a singleton, so it has a reference to current activity, so the old one is going to be the new one, and the task are actually going to be the new one. Can it be done this way?
It probably could be done. Your application, it stays around. So one thing that is safe to do is if your asynchronous task just needs a context, both the application and the activity are contexts, and contexts are just what you need to do freaking anything in Android. So it's safe to give your async task an application context that's still going to be around. Now, your application context doesn't automatically have the current instance of its activity. You could attempt to store that on there. It's tricky because there's this, you could attempt to do that in your onCreate method, for instance. I don't know what effect that would have. Anybody tried it?
Actually, I did, and I think I got to remove it because, as you said, if someone just turns another application on, my activity needs to be killed, yes, and I got reference to an empty activity again.
Yep, you don't want to hold on to that activity reference, which is exactly the other problem of this little async task hanging out there. Because it's an inner class of a fragment, which is on an activity, it has a reference. And in this case, I think it only has a reference to the fragment. It has a reference to its containing class. So this is holding on to stuff. You really have to watch that. It's really tempting to instantiate other classes with your activity, but that's dangerous. It's all about memory. Okay. So from here, we have almost 20 minutes. And we can talk about how to store data on the device. There's 4 options to this. We've already talked about content providers a little bit. Ooh, let me show you that. That'll be fun. Let's look at how Transmit integrates with contacts. This is kind of interesting. Okay, so let me take you through the flow of that, of how we pick a contact and put it on the screen. because I talked about how that works, but we can follow it through the application. All right, so the buttons fragment gets created, and we can find the pick contact button in its layout. That's right here. Text is pick contact. If I could, I would love to turn these into Polish, but it's not working. So the easiest way to determine what happens when a button is clicked is to set the onClick attribute here. The other way is to set it up programmatically in your onCreate method. One of the negatives of the fragments is that this onClick method does not go to the fragment holding the button. That would be too easy. It goes to the activity. So I have my activity pass it on to the fragment. All right, and what does that do? Here's where it launches the pick intent. So it creates a new intent with action pick. And I hate this word. Contacts contract dot contacts dot content URI. Ugh. All right, which is called this confusing thing for historical reasons. And how do you know to do this? You look at the source code. There are tutorials for a lot of this stuff, but the API docs contain these constants. And then once you have the intent, there's two ways to start it. Start activity through the intent, or start activity for result. In this case, I want to know what contact the user picked, so I use start activity for results. And I give it the intent and a secret code. This is just some integer an integer constant, doesn't matter what it is. What matters is that I look for that secret code in onActivity result. Yet another hook. 15 minutes, good. All right, so in onActivity results, I look for that code and I make sure that I got okay, because if the user just hit back or in another way exit out of pick contact, I won't get a good result. I'll get like result canceled. So, but if I get this code and okay, then I do some stuff with it. So there's actually two data accesses in here, but the one I want to show you is how we get stuff out of the contact. All right, that's going to happen in here. Load name and ID. All right, what we got back. What we got, dang it. What we got back, I want to show you where this was called. There it is. From our activity result is another intent, because intents are the message passing platform or message passing tool for the Android platform. And so we sent one out, pick contacts popped out and did its thing, and it sent one back to us, another intent. What's in that intent? Haha, this is where the debugger comes in really handy. So it's going to depend who picked up your activity. This one happens to be pretty darn predictable. Most Android devices use the same contact manager. HTC, of course, doesn't. But even their contact manager conforms and sends me back an intent with some data. So this intent can have the same things that every other intent can have, but often the interesting stuff is in data. And that's a URI. And this is a URI to a contact. So then what we have to do, and this is why transmit application needs permission read contacts, because all we get back from the pick intent, the pick activity, is the URI of the contact. And then we have to go to the content provider, which we get from the context. Actually, we get a content provider resolver from the context, and we ask it for the content provider that can give us a contact. And it gives us that. Content resolver, here we go. All right, and what we do with that, the content resolver, is query. And let me back up a minute. I said that really confusingly and also wrong. We get a content resolver out of the context, and we don't have to ask it for a particular content provider. We just do a query, and it figures out who has that data based on the URI. All right, so we give it this URI, which is in yet another, this particular one is loading the email. Let's start with load name and ID. Okay, so we give it the contact URI, and we ask it for columns. So content providers operate just like the database, and this is a commonality between content providers and the SQLite database that's built in on Android. In both cases, you're going to run a query on them, and you're going to get a cursor back, which is a lot like a SQL cursor, but of course not the same. And here are a whole bunch more constants that you have to dig out of the API documents to figure out what column names you have to pass in order to get the data you want. And it's kind of complicated. And the queries, they're not pretty. But then it's a cursor, move to first. You have to retrieve the information by column number, not column name for some reason. That actually drives me crazy. And great. So this is how we integrate with the content provider. And we get the email address and the name. It's not pretty. That's a lot of Android. It's not pretty, but it is really useful. Then the other thing that we do with that information is I'm using save preferences on the URI. And so this is the second way to store data on the device, and it's also the easiest. So you can use a content provider, and the purpose of that is to let other applications access your data. But if all you need is to save some stuff for your activity, preferences are the easiest. Obviously, this is intended for like user settings and stuff, but you can use it to store any simple data. This winds up in an XML file on your application's internal directory. So again, nobody else can read it because of Unix file system security, unless you do something different. And each activity has its own preferences file by default. The only weird thing about it, and this is a good kind of weird, is when you get the preferences and you want to add one, you call edit, and then you have this Fluent API, and then it's yet another key value store, so you can put your strings in there, and then you call apply. So the preferences are an XML file, but writing to it is transactional. So you can set a whole bunch of preferences at one time in this Fluent API, and then call apply to save it to the file, and it'll even do it off thread automatically. If you say commit, it'll do it on the thread. Apply is newer. All right, so that's, yes. Yes, it's persistent in an XML file in your internal storage. So that's the second way to store data. The third way is files. I mean, this is Java, and you have access to two different kinds of storage: internal storage, which is your application's private directory, and external storage, which is typically an SD card, but is not private to your app. I can access through ADB shell everything that's on the SD card in my phone, or the internal, it's still called external memory in Android, but I can't pull it out of my tablet. That I can access through ADB, and I can push and pull files to and from it because everybody has access to that directory. So file I/O, you can just do it in the normal Java way. And finally, the SQLite database is built in, and SQLite is actually, it's really cool. It's embedded in a lot of places. It's in your OS, it's in your browser. It's on a lot of devices, because the whole database, the executable is under 200K, and it does almost everything SQL does. Except it doesn't do, what it doesn't do that you're used to is ask you for a login. You open the file and you have access to the database. And it doesn't encrypt. It's just a file. And then Android provides a whole bunch of complicated ways to interface with it. So I can show you that, or I can show you anything else in Transmit, or what do people want to talk about? We have 10 minutes? 5 minutes.
Gestures?
Oh, you want to see the gestures? Okay. So gestures are weird. They are, I think that's in the picture fragment. And then in the on create, or on activity created, of course, I set up the gestures. So to create gestures, you have to, if I recall correctly, you download an app that will create the gestures library for you. So yeah, I get a gesture library, which is actually a raw resource in my APK. And I created that with this gestures app that I downloaded, where you can draw and then it saves it. And then inside that application, you also name each gesture. And then I get this view is just, it's just a box around my, the gesture view is just a box around the picture. And I set up this gesture performed listener that checks which one it got. So I've got 3 named gestures. I can go to an older picture, I can go to a newer picture, or I can transmit, and this is where I handle them. So it's kind of interesting that you have the extra step of downloading a particular app to create the library that then goes into your APK. I don't remember. Just Google it. Yeah, so let me flip to the last slide, which is further resources. Developer.android.com is getting better and better all the time. There's so much more documentation than a year ago when I started doing this. It's crazy. It's really quite good. There's a lot of tutorials. There's a lot of screencasts and podcasts that you can find. Stack Overflow is your best friend. A lot of people are doing Android, and they're really good about asking and answering questions. And finally, there's several books out on Android. The one I like is Programming Android 2nd edition, which just came out a few days ago, so it's really current. I like that one. And just in case, that's the link to all of my prezzies, including this presentation. Any other questions? Yes.
Basically, about the life cycle of the application. When something goes wrong in my application, there seems to be a dialogue. For example, I get a null pointer exception I didn't catch somewhere. So I got the dialogue that this application is bad, blah, blah, blah.
Your application has stopped unexpectedly. Force close.
That's it. And the application is killed.
Yes.
So I would like to catch that event. So I'm making a thread that is monitoring the exceptions, which I haven't handled.
Ooh.
So there I can't seem to kill the application after I process. Yeah, I would like to know if someone knows how to make it happen.
Okay. I don't, but I know someone who does know a lot about handling errors specifically. It's a different method of handling errors, but Andre is one of the speakers here. He did a workshop a couple days ago, and I was talking to him last night, and he had a very similar problem in his Android application.
Because I would like to know what happened, and I'm asking users to send feedback, but I can't seem to kill the application.
Ooh, he has a great way to do that. And he was going to show it to me at some point, but I haven't seen it yet. But if you can catch Andre here at the conference, ask him that question, because he has a really good solution for tracking errors. Okay, so thank you guys. You didn't talk nearly enough, but other than that, you're a great audience.